So now we're going to do a few more here. And if you're graphing this by hand, you're going to realize that we can't actually graph this one yet, at least not as it is. There's a few ways you could graph it. You could try to get it in y equals mx plus b before you graph it. Or you could just graph the x and y intercepts because they actually work out really nicely. So that was something you learned in Unit 1 when we did the standard form and we graphed it. So essentially, if you just cover up, so if I just cover up the x, you can see that y divided by that 2, so y equals 1. There's your y-intercept. So I can just plot a point right there at 1. And then repeat that process. Instead of covering up x, you're going to cover up, in this case, y. So if we were to cover up the 2y, we see that negative x equals 2. So you really need to divide by negative 1, and you're going to end up getting that x equals negative 2. So now we can go over here and we can graph that point right there at negative 2. If you are still wanting a few more points after that, what I would do is just realize that my slope is 1/2, so I could go up by 1 and over 2, up by 1 over 2, up by 1 over 2, and kind of continue from there. So once you've got those points in, let's draw our line as usual. All right, so our line goes like so. All right, and then we're going to do the next one. The next one's a little bit easier because it is in slope-intercept form. So right here, we're going to start at positive 1. Okay, start at positive 1. And then we're going to do the same thing. We're going to go up 1 over 2. Interesting. Up 1 over 2, up 1 over 2. So what you're noticing is that this line is actually exactly the same, right? They didn't look the same back up at the beginning. At the beginning, they looked quite different from each other, right? But when you graph them, they're actually the exact same line. So because they're the same line, if you reference your notes up above, when you have the same line, remember that simply means that you have an infinite number of solutions. So our lines are actually the same in this case. So you have to still write this down. We have an infinite number of solutions. Infinite solutions. Okay? But it's really important that you visualize that. Got to graph it. Let's do the last one here. Example B. So you should start to notice already that your slopes are the same. And if you remember back to Unit 1, that meant if your slopes are the same and your y-intercepts are different, you should already be thinking parallel, right? But let's confirm our kind of our guess here and see if we're right. We'll start out, this one will be red, so I'm going to start at positive 2, up 2 over 1, up 2 over 1, so on and so forth. So my line looks something like that. And then we'll do this one down here in green. So this one starts at negative 1, up 2 over 1, up 2 over 1, up 2 over 1. So my line looks something like, oof, missed pretty badly there. Let's try that again. My line looks something like this. And again, our guess is confirmed. These lines definitely are parallel, which means we can't just say they're parallel. It actually needs to tell us what that means. It means that they're never going to intersect, right? There's no intersection. So if there's no intersection, then that means that there is no solution. We have no solution at all. So really important that visually we wrap our minds around what this is actually saying. So what I would encourage you to do is we're going to be able to use Desmos from here on out. But anytime you have Desmos available to you, you can graph your equations and then look at whether they intersect or not. And when they do intersect, just click on that point of intersection, and there you are. You have your solution. So the very last video is just going to be an example of what that looks like.